video, we're going to talk about FRQ type number 3 of AP Precalculus. So there's already a question on the same type on my channel. I'll make sure to put a link in the description. You can check that out as well. It's also a good question. So let's read this one out. It's about a wall clock, of course, as we can see. Okay, the figure shows a large clock mounted to a vertical wall, and the clock has an 8-inch long moving minute hand, and the center of the clock is 120 inches directly above the floor. Okay, I would prefer to annotate as I read. So the center of it's not a great ink. The center of the oops, the center of the clock is about 120, not about exactly 120 inches from the floor. And at time t equals 0, the minutes hand is pointed directly up at the 12 o'clock. So as it's shown in this position. However, the clock is not working properly and the minute hand is moving twice as fast as it should. Interesting. Thus, the next time the minute hand points directly up to 12 minutes, up to the 12 mark is at 30 minutes, which makes sense, right? Because ideally it would come at the same position after 60 minutes, but since it is moving twice as fast, it's going to take half the time. So 60 over 2 is definitely 30 minutes, which makes perfect sense. As the minute hand moves, the distance between the end point of the minute hand and the floor periodically changes, decreases and increases, which makes sense, right? Right now, the minute hand is at what distance? The tip of the minute's hand. It is definitely 120 plus 8-inch, because the length of the minute hand itself is 8-inch, right? So this is going to be 8-inch, and it makes sense that when the minute hand comes at 3, its height is 120. When it is at 6, the height is 120 minus 8, and so on and so forth. The periodic function h models the distance in inches between the end point of the minute's hand and from the floor as a function of t in minutes. Okay, cool. The graph of h and its dashed midline for two cycles is shown. So this is the graph, and this is obviously the midline. 5 points f, g, j, k, and p are labeled on the graph. No scales indicated, no axis is presented. Determine the possible coordinates in the form of time, and h of time means the height. For the 5 points f, g, j, k, and p. So obviously f is the highest point, right? And when is the height highest? Because this is nothing but the highest point, as we can clearly see. And the highest point means the highest the highest height. So the highest height is definitely 120 plus 18, which is exactly as it is shown right now, because that is the maximum height from the floor. So that's going to be 120 plus 8, which is 128. So I know that at t equal to 0, the height is 128 inches. So that's how they want the coordinates, t comma h of t. So t is just 0, and then it is just 128. Makes sense, right? G is the point where it is at the midline. So obviously it makes sense that it is at the midline when it reaches 3. So what is the time for it to reach 3? Generally, it would have been 15 minutes, but the clock is moving twice as fast. So it will take half the time, which means that it is going to take 7.5 minutes, right? Can we agree on that? 7.5 minutes. And the height is just 120, right? Because there is no additional height offered by the by the minute's hand. So it's going to be 7.5 comma 120. Then J, I think you might have predicted by now, is the minimum guy. So the minimum thing is when it is at 6. So what is the height? Obviously, this is 8 and this is also 8. So you're looking at the height of the 6 from the floor, which is going to be 120 minus 8, right? 120 minus 8. So this is going to be the height from the floor, which is 112. And what is the time? It's another 7.5 minutes, which is obviously 15 minutes. Then we have k. It's very easy now. K is once again at the same position. It is at the 9. 9 is at the same position or the height as of 3. 3 is already 120. So k is also 120. And the time is going to be 15 plus 7.5, which is 22.5 minutes. And finally, P just comes back at the same point, which is 128, same as F. So 128, and the time is of course 30 minutes, which adds up because they also tell us that it's 30 minutes for one complete rotation, and 22.5 plus 7.5 is also 30. So yeah, our work is correct. Okay, nice. Okay, part B is refer to the graph of H in part A. Okay, there we go. The t coordinate of G is T1. The t coordinate of G is T1. Huh, that's confusing. The t coordinate of G is T1. Where is G? There you go. What is T1? The t coordinate. So this is T1. And the t coordinate of J is T2. Where is J? J is here, and this is T2. Okay, cool. Now the interval of T1 to T2, which of the following is true? Huh, there was no need to mark it anyway. We could have just said that, this is the portion which they are talking about, G to J. So this is what they are talking about. So they are saying that in this interval, which of the following is true? Okay, all right. It's just positive and increasing, huh? It's not increasing for sure, because we can clearly see that it is decreasing in nature, correct? It is decreasing in nature. So it has to decrease here. So it has to decrease, it has to decrease. Now the question is whether H is positive or negative. So although I, for a minute, for a second, thought that H is negative because I was thinking for this to be the x-axis, but remember, there are no axes given over here. And you can clearly see that the height is never going negative. It's always positive, right? So it has to be positive, and it has to be decreasing in nature. So option B makes absolute sense. Hmm. And the last one asks about describe how the rate of change of H is changing. Remember, rate of change is changing. So they're asking the rate of change of, the AROC, the change of AROC, if it makes sense. What is AROC? Average rate of change. I'm just going to write it over here. So they are asking how is the average rate of change changing? AROC, average rate of change is changing. And what is average rate of change? What is the change of average rate of change? Average rate of change, only AROC represents whether the function is increasing or decreasing. So if I say that AROC is positive, it means that the function is increasing. But if I say that the change of AROC is positive, it means that the function is concave up. I'm sorry, I will come again. What I meant is, if the average rate of change is increasing, then it is concave up, or vice versa. If it is concave up, then the average rate of change is increasing. And if it is concave down, then the average rate of change is decreasing. All right. However, if I just say that the average rate of change is positive, so it means that the function is increasing, nothing to do with concavity. And if the average rate of change is um, negative, then the function is decreasing. So there are two separate things. Please be careful about how the question is being phrased. So as of now, they are just asking whether the the rate of change, the average rate of change, how is that changing? Is that increasing or is that decreasing from T1 to T2? So you can clearly see that from G to J, it's a smiling face, and a smiling face is concave up, and in concave up, the average rate of change is increasing. So the answer to this part would be it is increasing in nature. Hope that makes sense.